Various manufacturers of boilers may arrange their controls and components differently, but all will utilize the same principles of steam generation and combustion. Whether the boiler is water tube construction or fire tube construction, the combustion controls assist the fireman to accomplish safe and economical power generation. The fireman is charged with the safe, efficient performance of the boiler on the water side and the fire side. The operator's manual is a necessary aid to the fireman and outlines the proper operating procedures. Knowing how to manipulate controls and read gauges is important for today's fireman. He must be able to accurately tabulate on the log sheets all the readings taken while on duty. These records will be used to determine fuel consumption, operating efficiency, and the frequency of flue gas analysis. Part 2 of this film on boiler operation will explain the controls and duties of the fireman on the fire side of the boiler. The basic boiler fuels, gas, oil, or coal, require different feed systems and combustion techniques. Fuel oil requires atomization. Natural gas does not. A typical oil feed system utilizes pumps, strainers, heaters, and pressure relief valves. Oil is drawn from the storage tank through strainers and is pumped to the heaters. A check valve, shutoff valve, and other control devices may be utilized at the oil storage area. Heavy fuel oil ignites easier when it is heated. Steam or electric heaters may be used both at the burner and in the storage tank. Be sure that oil is never heated to the flash point in the storage tank, but is kept between 100 and 120 degrees Fahrenheit for best results. Pressure relief valves at the oil inlet and at the boiler are employed to maintain a set pressure and to bypass excess fuel back to the storage tank. The combination of fuel oil controls at the boiler is called the fuel train and may include another strainer, heater, relief valve, and other devices. Various manufacturers will use different control assemblies. The fireman must know the fuel control assembly for his particular boiler. The pressure regulator controls the pressure of the oil at the metering valve. The fuel pressure gauge indicates the pressure at the metering valve. The metering valve regulates the amount of oil flowing to the burner and is operated by the modulating cam. The modulating motor enables the boiler to follow the load demand when in the automatic operating mode. It actuates the oil metering cam and the combustion air damper to control the mixture of oil and air to the burner. Ignition of the fuel oil is accomplished by a gas pilot flame. The gas pilot valve is energized by a signal from the programmer to let gas flow during the ignition period. If the pilot does not ignite when required, the ignition system shuts down. On some boilers, the gas pilot solenoid closes after the main burner flame is established. The ignition transformer is energized at the same time as the pilot solenoid and produces a high voltage spark at the tips of the ignition electrode. At startup, the spark from the electrode ignites the pilot gas. The pilot flame is used to ignite the burner when the programmer calls for delivery of the air-oil mixture for main flame. For satisfactory combustion, the fuel oil must be atomized as it leaves the nozzle. Atomizing air, or primary air, is pumped to the burner nozzle where it mixes with the oil and provides the proper pattern in the combustion chamber. An atomizing air pump may be driven by the blower motor. Steam or compressed air may also be used on boilers to atomize oil for combustion. The air oil receiving tank supplies lubricant for the air pump and separates the lubricant from the primary air as it passes to the nozzle under pressure. The air gauge on the burner manifold indicates the primary air pressure to the burner. The grooves in the swirler inside the burner nozzle impart a swirling motion to the primary air and fuel oil. Primary air is not to be confused with the forced draft or secondary air in the combustion chamber. In most boilers, the burner unit is readily accessible. To burn oil in a dual fuel boiler, the oil burner assembly must be placed in the burning position. The fuel selector switch is set to oil, and the oil heater switch is turned on. Fuel should now be available when the programmer calls for it. The program controller provides automatic sequencing of the ignition cycle and shuts down the boiler if anything goes wrong during operation. At startup, the controller first turns on the secondary air blower. The modulating motor also opens the air damper wide so that air can be blown through the combustion chamber to purge it of any unburned gases. After a timed purge cycle, the gas pilot solenoid valve opens to allow gas to flow to the pilot. At the same time, the ignition electrode provides the spark to ignite the gas pilot flame. If the flame scanner senses the pilot flame, the sequence continues. If not, the programmer will interrupt the sequence and shut the boiler down. The sensing device in the scanner may be a sulfide cell, an ultraviolet detector, or other type of apparatus. When the pilot flame is proven, fuel is directed into the burner and ignited. The flame viewing window permits the fireman to observe the flame. The scanner now monitors the main flame and shuts down the fuel valve in the event of a flameout. When main flame occurs, the ignition sequence is complete and the program timer halts at the run position. When the burner is turned off by an operating pressure troll or flame failure, the timer will run through a post-purge sequence and stop at the ready position to start another firing cycle. While the program timer is stopped at the main flame or run position, and with the controller set at automatic operation, the modulating pressure troll will control the flame according to load demands on the boiler by means of the modulating motor, cams, and dampers. A boiler gas fuel system is slightly different from the oil system just described. Gas for the pilot and main burner may be supplied at main line pressure. In a typical gas train, the first item in line is the pressure regulator, which reduces the line pressure to the pressure required at the burner. The manual gas valve provides a shutoff for the gas line to the main burner. The pilot gas train is tapped ahead of this main gas valve, so the pilot flame can be used for either fuel. The motorized main gas valve is an electrically activated shutoff valve. In the event of any boiler malfunction, such as flame failure, low water, or excessive steam pressure, this valve springs closed to shut down the main burner. Insufficient gas pressure, detected by the vaporstat, would also cause shutdown. During the normal ignition and combustion cycle, this valve is opened and closed by the programmer. Gas flows through the motorized valve to the modulating butterfly valve, which controls the flow of gas from low fire to high fire settings. The position of the butterfly valve disc is governed by the gas modulating cam. The butterfly valve and the combustion air damper are controlled simultaneously by the modulating motor, which varies combustion air and gas for changes in boiler load demand. To change from oil to gas on a dual-fuel boiler, a specific sequence is followed. The fireman turns the control switch to the off position. The fuel selector switch is set for gas, and the heater switch is turned off. The belt is removed from the atomizing air pump, and the burner is withdrawn from the boiler, making certain all oil is drained and the burner is clean. On some boilers, the burner unit is not completely removed, but is simply pulled back and locked in the inoperative position. The main gas valve is opened. The control switch is flipped on, and the programmer initiates the ignition sequence as it did for burning oil. The modulating cam moves the draft lever and the butterfly valve disc as the programmer calls for changes in the air-gas ratio to meet load demand. The same modulating motor operates the cam for both fuels. Draft air is a very necessary ingredient in combustion. It can be either forced, induced, or natural. The control of the draft will determine the heat of the flame and the types of gases vented to the atmosphere. Today we hear as much about air pollution from stacks as we do about efficient utilization of fuels. In air pollution control, the important concern is emissions to the atmosphere. Undesirable products such as particulate matter, unburned hydrocarbons, and other gases are carried into the flue along with the products of complete combustion, which are carbon dioxide and water vapor. In a forced draft system, a blower on the front of the boiler forces air into the intake located just above the motor. On an induced draft boiler, the fan would be located in a stack and would pull air into the combustion chamber rather than push it. On most boilers today, the control of the draft, as well as the fuel supply and the fuel-air ratio, is automatic. The draft control linkages on the front of the boiler are driven by the modulating motor in response to signals from the programmer. Movable shutters on the damper, operated by the linkage, control the amount of air that will be allowed to enter the burner. When the linkages are properly adjusted, a coordinated movement of the damper and metering cams within the limits of the modulating motor travel will provide the proper fuel-air ratios through the firing range to meet the load demands on the boiler. The stack temperature thermometer tells the fireman if he is getting full utilization of combustion gases. If the temperature is higher than normal, flue gases are not giving up heat to the water, perhaps because of dirty boiler tubes. A boiler fireman knows the equipment for which he is responsible and practices safety while applying the principles of combustion and steam generation. At all times, the fireman is governed by insurance, state, and local regulations, and the procedures established by the owner of the boiler. As the technology of boiler operation advances, the fireman must constantly update his skills to obtain the safest, most efficient performance from his power generation equipment.